Hello, what we have here is a power cycle that transfer hot temperature hot energy to a cold reservoir. Here's a little diagram that I sketched out, and essentially we need to compare the following cases to the system right here, that whether if they are for each one, if it's reversible, irreversible, or impossible. So to approach this, we need to go ahead and look at the Carnot efficiency, because Carnot efficiency tells the maximum efficiency of a system. And for our case, it will be 1 minus T cold over TH. And that would be 1 minus 400 kilojoules divided by 1,200 kilojoules, which is turned out to be 66.7%. And the reason why Carnot efficiency is the maximum efficiency, because this is when we assume that Q is equal to T when ds is constant. And that's bringing me to my next point, that when ds is constant, it's considered reversible. And I drew a little diagram here of consider what's a reversible and irreversible system. So reversible system, like let's imagine like these are pebbles, and in state 1, when you start off with 3 pebbles, and then when you finish with 3 pebbles after you go through your cycle, then that's considered reversible, because you start off, the amount of pebbles you start off is equal to the amount of pebbles you finish, and and the opposite of that is irreversible, because if you start off with 3 pebbles and you only finish with 2 after you go through your cycle. And in order to solve this problem, we need to set some conditions, because like I said, so for a reversible system, is you need to start off what you have. So basically what you start off is equal to the amount that you have to the amount that you finish. So the conditions that we're going to set for this problem is a condition. So like I said, for reversible, what we start off obviously is the maximum efficiency, and these are the conditions what he finishes. And so these are the conditions that we start off with. So if the efficiency for each case is equal to the maximum efficiency, which is 66.67%, then we consider it reversible, right? And like how I said, if it started with less than the maximum efficiency, we'll say that it's irreversible. That's irreversible. And if the maximum efficiency is greater, if the efficiency is greater than the maximum efficiency, obviously that's impossible, because you can't have that. So let's run down through each of the following cases. So for A, we have QH is equal to 900 kilojoules, and the work is 450 kilojoules. So to find the efficiency of this, we just simply so we have efficiency divided by work divided by Q hot, which is 450 divided by 900, and that's turned out to be 50%. And when we compare that to the maximum efficiency that we have of 66%, so 50% is obviously less than 66%. The max, and we would say that is irreversible. Okay, for B, we have QH is 900 kilojoules, and QC is 400 kilojoules. So the same thing, efficiency is equal to the work, which is 400 kilojoules divided by 900 kilojoules is equal to 55%. You run that into the calculator, and obviously that's still less than 66.67%. So we say that it is irreversible. And for C, what we have is, what's given to us as the work is 600 kilojoules, and they're actually giving us the Q cold, which is 300 kilojoules. But remember, so from our first law of thermodynamics is dq minus dw. So the internal energy is 0, so that means dq is equal to dw, and the work final minus work initial is equal to Q hot minus Q cold. So the equation that I've been using to solve for efficiency is work divided by Q hot, but what's given to us is Q cold. So we need to replace Q hot with Q cold, and we can do that by solving for Q hot, which is just essentially Q hot is work plus Q cold. So we just substitute back for Q cold. Go work plus Q cold. You have 600 kilojoules divided by 600 kilojoule plus 300 kilojoules. That's 2/3. So that is 2/3 kilojoule, which is 66.67%. So the efficiency of C is equal to the maximum efficiency. So we say for case C, we say it is reversible. And the last one, what's given to us is an efficiency of 75% of a system. So if the efficiency is already 75%, we can just compare that to the maximum efficiency, which is obviously greater than the maximum efficiency of 66.67%. So for case D, it is impossible. Yeah, that wraps up all the video, and here's proof, Jindar Heng, that I did the problem, and thank you very much for watching.